Good afternoon, my name is Matúš Pivovar and I am PhD student. I am responsible to processing and analysis of remote sensing imagery. The topic of my presentation is related to remote sensing of the Earth, and in this work I specialize in information obtained from multispectral and hyperspectral images from mission Sentinel-2 or Dragon 50 unmanned area vehicle. I would divide the presentation into 4 parts. First, we will briefly cover some introduction about the relationship of the bark beetle to its hosts and remote sensing. Next, I would like to interpret for you part of the result of the scientific community, which serves as the main pillar of our research in the issue analysis section. The third part of our presentation deals with the aims of the dissertation, which are also the aims of the 2 researchers. And finally, I would like to give you an interpretation of our research today, touching on the results we plan to publish. I will start with a general observation on the relationship of bark beetle versus spruce. Bark beetle are one of the most common pests in the world coniferous forest, where they cause increased the mortality at the landscape level and destructive impacts on forestry and the environment. For the most recent period, we can see on the left-hand graph the European situation up to 2021. Let's move on the second part of our presentation, discussing the dissertation issue analysis. There are several physiological and biochemical changes. Let us call them together symptoms of analysis. Instance, attacked by the bark beetle, which are related to the survival of the trees themselves and have a direct impact on the mechanism of the spread of the bark beetle infestation. The initialization and spreading of the focus plays an important role in our work. As we have created 2 classes named as spread and initial using the mechanism, I will interpret them later in this presentation. So, I would like to briefly interpret a common process of preparation of remote sensing data for our purposes. The first point points out the application of various channel corrections to multispectral or hyperspectral images. In the next point, we choose to use supervised classification for selection of disturbances and healthy forest using maximum likelihood classification. We statistically supported our efforts of producing an appropriate classification with accuracy assessment tools. Spatial characteristics, which we will get to later, were divided by classification class. We converted the data thus prepared into a table and applied boosting regression trees. The fourth part of the presentation is the aims of the work. We focus on attention exclusively on monitoring changes in a spruce forest from a spatio-temporal perspective caused by bark beetle. In parallel, we have monitored physiological changes using vegetation indices. In contrast to previous modeling, the modeling of the spread image at the tree level is tracked over a single time horizon. The aim of our work were supported by hypotheses about the relationships between bark beetle and their hosts measured by remote sensing in Suchá-Dolina Valley and Ochoa. In the Suchá-Dolina Valley, we considered the spread and initiation of bark beetle outbreaks in a spruce forest area. In the spruce stand nearby the village Ochoa, we consider an increase in the infestation of bark beetle on the forest edge, which is lighted. To start the 5th part of our presentation, which is on materials and methods, I would like to show you our study areas in false colors. I would like to highlight the fact that for the hyperspectral aerial remote sensing imagery, we have only one time point from the end of July 2021. On the other hand, in the case of the multispectral imagery, this is time interval of image collection from 2015 to 2021 in October of each year. The study in the Ochoa forest district is located in a 90 years old healthy spruce forest stand at an altitude about 565 to 575 meters above sea level, which falls under the economic forests. The edge of the stand was damaged by the wind calamity of 13 August 2018. The trees are divided into two groups, namely forest edge and core stand. The the goals of this research is to investigate the relationship of understory insects to their host at multiple levels of observation. On the next slide, I will take the opportunity to present the data that enter into our research. As you can see on this slide, data collection is being done from many levels of observation of the bark beetle. Terrestrial data or parameters were collected from tree trunks, but also from the activity of bark beetle on individual trees. These data are just being linked to information provided from hyperspectral imagery analysis, such as identification of canopy water potential, proportion of pigments, needles, and so on. On this slide, you can see a selection of the lighted part of the canopy of both groups of trees from the ratio of chlorophyll, carotenoid, and anthocyanin in the assimilation system to needle senescence and water potential. We statistically verify this data using ANOVA analysis. On the next slide, I would like to turn to monitoring and modeling to distribution of bark beetles in the Suchá-Dolina Valley area in the High Tatras. Before I begin, I would like to inform you that the maps are ready for publication. The study area of the Suchá-Dolina Valley is located in the non-intervention zone of High Tatras, with an area of the 4,000 hectares, which is approximately 5.5% of the area of the national park. The composition of the vegetation consists of natural homogeneous spruce forests and higher altitude stands of mountain pine. The altitude ranges from 890 to 2,100 meters above the sea level. The climate is characterized by a low average temperature. The area is situated in a more challenging terrain configuration. In May 2014, the area was affected by the wind calamity named Jofia, which covered an area of more than 400 hectares. Since 2016, there has been a gradation of bark beetles. If I could summarize the process in the study design, we captured the complex process of creating and processing the classification of all the images. I would divide the study design into three parts. First, data collection and processing. Second, classification accuracy determination. And finally, prediction analysis. I have taken the liberty to simplify it, but it is complete in the thesis. I would like to show you an intermediate classification processing step from the 2015 image. I would divide the classified classes into basic parts: healthy spruce forest, wind or bark beetle, pine forest, rocks and logging. The proportion of the stand where bark beetle was present we assessed starting in 2016. Due to the high terrain configuration and the time of imaging our area from space, we decided to specify the classification by creating training sets or samples separately and shaded and lighted slope. In 2015, we studied the healthy forest and the wind calamity, and in the following years, we focused only on the spread of bark beetle outbreaks. After creating a supervised classification, we applied a set of vegetation indices, the rasters, while creating a consistent set of spatial data such as slope, solar radiation, distance of forest from the bark beetle outbreaks, and so on. We focused only on healthy forests and forests damaged by primary or secondary attack of bark beetle. We named the primary attack as initial and the secondary attack as spread. We then took vectors of healthy forests on both types of bark beetle outbreaks in 2016 and applied them to rasters from a set of vegetation indices and spatial characteristics. We exported the data into a single matrix for each year and applied machine learning analysis called boosted regression trees, what I mentioned before, to the data of predict the bark beetle spread. On this slide, I would like to show you the classification classes studied and choice of parameters for prediction analysis. The differences between the spread and initial class is that the spread touches some part of its own area from 2015 wind calamity or the area of the bark beetle spread from the previous year. The initial class, on the other hand, we created by the bark beetle flying over new territory that was not damaged by the wind. The parameters below as independent variables are used in the boosted regression trees analysis. Let's look for a moment at the map created by the classification algorithm and later edited by me that shows the gradual spread of bark beetle in spacetime in the non-intervention zone of the national park. The proportion of damage caused by bark beetle is several times higher than the wind damage to the forest over the study period. As you can see, the overall classification accuracy is approximately 92%, which represents a high quality classification of maximum confidence. The influence of the random component is interpreted by the kappa index, whose average value is 0.88. The influence of the random factors was statistically insignificant. I have also shown the curves of forest damage in graphical form. In the graph we can see that in 1 year time horizon, wind calamity caused the greatest damage. On the other hand, we can observe almost half increase in forest damage by bark beetle in 2 consecutive years. We can see that the negative trend has not stabilized. On the contrary, there is probably another wave just 4 years after the first attack. On this slide, we observe damage to the forest by the bark beetle. Since 2015, bark beetle has expanded by 2% of the total spruce stand area in the initial class. Bark beetle attacked the healthy forest that was a minimum of 50 meters and the maximum about 400 meters from another forest damaged hotspot which suffered from higher physiological stress. Let me draw your attention to the 2018 plots where the distance parameter does not feature as a primary one. The role of senescence is important where we assume that it invaded other stand. The spread class follows a similar pattern to the initial class in some respects, for example in the relative dependency rate of the distance parameter. Unlike initial, for spread distance is important in every year. With greatest distance from the focus of the wind calamity, the pressure of bark beetle decreases. It attacks trees at relatively middle altitudes with a lower proportion of chlorophyll in the needles. In the following years, the importance of spatial characteristic and vegetation indices level off. The course of the spread seems to be slightly different from year to year. Finally, let me sum up our effort in 4 points. We can reject all the null hypotheses we have developed for the time being because bark beetle have caused changes in the physiological state of the stand for a varying degrees. As a part of observation of bark beetle insect in the Sucha-Dolina Valley, the paper will be published shortly on the Web of Science platform, where I will participate as a lead author with my supervisor Dr. Jakuš, then Dr. Meze and Professor Juriachova. In the context of the observation of vegetation near the village of Očova, after linking the terrestrial and aerial data, we are going to publish another paper where I will participate as a co-author. Finally, I would like to mention our activity within the Horizon Europe project and our future collaboration with Italian scientists in monitoring the initiation of spread of bark beetles in the Trento area of Italian Alps using the Tanabo models. So thank you for your attention.